Okay, so we've got another question similar to the last one. Random variable, this time n is 40 and the probability is 0.1. That matters when we look up the table. Let's go ahead and dive straight into A. We need to find the largest value of k such that the probability that x is smaller than k is less than 0.02. We know that what we need to do here is get the tables up. Now it's a different table. This time we want the table for n is 40. But before we can go to the table, we need to do some thinking, because this says x is less than k and the tables do less than or equal to. So let's look at how that would affect things. Here's a number line and here's all the possible values: 0, 1, 2, 3, 4, dot, 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 dot. There's k minus 1, there's k, and here is k plus 1, and so on and so on. Okay, we want to have all the values which are strictly less than k. Strictly less than k gives us those. So we need less than or equal to k minus 1. We are in fact going to look up in the tables the probability for x being less than or equal to k minus 1. So the value we find will be k minus 1. So let's bring up the tables now. Good, this is the table for n equals 40. We need to look at the section where we have 0.1 for the probability. And as you can see, if we go straight here, we can see that the probability for x being less than or equal to 0 is below 0.02, but the one above it is greater than 0.02. I'm going to write that down. We've looked at these two values and notice that that's the changeover point between where one's below 0.02 and one's above 0.02. I'm going to write that down. So the probability that x is less than or equal to 0 was given as, so we saw that the probability that k is less than or equal to 0 was 0.0148, and the probability that x was less than or equal to 1 was 0.0805. This is too big, so our k value must be 0, or rather, k minus 1 must equal 0, which means that k equals 1. That's the answer to A. Well done us. So part B now, we need to find the smallest value r such that x is greater, the probability that x is greater than r is 0.01. Again, we need to adjust what we're looking for, because we can't look up in the tables or on the calculator a probability that x is greater than something. So the probability that x is greater than r is equal to 1 minus the probability that x is less than or equal to r. Let me just quickly go over that. If we got 0, 1, 2, 3, dot, 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 r minus 1, r plus 1, dot, 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 39, 50, well, sorry, 39, 40, because we're only going up to 40 this time. We want to find all the bits where it's greater than r, strictly greater than is up there. So the bit where it's less than r, or less than or equals r is what we want. Okay, let me just get rid of that. So therefore, 1 minus the probability that x is less than or equal to r must be smaller than 0.01. Rearranging, I get the probability that x is less than or equal to r must be greater than 0.99. It's time to look things up on the table. And so this time we're looking down the same section of the table. N is 40 and we want 0.01, and we're looking until we see where the value is greater than 0.99. Now if I come down here, just around here we can see the changeover. Probability that x is greater than or less than or equal to 8 is below 0.99, and the probability it's above, sorry, the probability that it's less than or equal to 9 is above 0.99. So our two values that we need to consider are 8 and 9. Which means that if we transcribe that now, we can say that, we can say that the probability that x is less than or equal to 8 was 0.9845. which is less than 0.99. The probability that x is less than or equal to 9 is 0.9949 from the tables. Therefore, the first one that's greater is x equals 9, so r equals 9. So part C in this question asks us to find the probability that x is between k and r. Now, the probability that x is between k and r is equal to the probability that x is less than or equal to r minus the probability. And it's probably worth just checking here. Let's just check a number line. So here's a number line with all of the values on it. So, sorry, just grab the pen instead. So it goes 0, 1, 2, 3, and then we had, we know the numbers, 4, 5, 6, 7, 8, 9, 10, 11, and so on. We're interested in the bit where it is more than, less, it includes k, but it includes r. Those are ones we want. So because we knew those values. Now that's interesting because if we do this, if we didn't know the k and the r, we would have to use here x is less than k, strictly less than, which means that we want the probability that x is less than or equal to 9 minus the probability that x is, that's an x, is less than 0. And we can look those up from the tables, or we can use the values that we found as we were looking, and that will give us, x is 0.9949 from the question part B, and 0.0148 from the work we did in part A, and so overall it's 0.9801. Job's a good one. Okay, you should now try number 9 and number 10. I'll be online to help you. Just ask for help. I mean, I don't expect you to do these without any support.